here we're going to do two overview videos highlighting how Softtree's terrain tools can be used to analyze cable deflection for forest operations. Now the first video we're going to focus on using the tool relative to existing infrastructure, so using existing roads. The second video we're going to use the tool to locate proposed landing sites and then design a road to access those landing sites. Now, regardless of which workflow or project type you're working with, these tools are effective to help us plan our blocks, plan our landings, and plan where roads need to be established to access those landings. Beyond that, though, it can also help select what equipment and systems are appropriate for logging a particular block, identify areas where ground lead may be problematic, specify tail spar heights and locations, and determine max piece size for bucking, helping us to ensure harvested timber is recoverable. Now, all of this helps planners maximize profit and minimize operational disruptions, but it also helps them minimize environmental impact. So that pans out in several ways. One, a plan that has little disruptions in it will have fewer people cutting corners during its implementation. Two, it helps planners see how they may interact with sensitive areas and reduce that interaction. And three, from a wildfire standpoint, it helps planners reduce fuel load in the forest or that post-harvest block, helping ensure that all merchantable timber is recovered or recoverable. So with that, let's dive right in and start a project from scratch. The first thing I'm going to do is insert my spatial data, and for that I'm going to start with my surface information. Now we work with a wide variety of formats. So common surface formats would be DEM data, and that's what I'll work with here. So I'll use a DEM in a TIFF format, but it could be a DEM in another format such as IMG. It could be LAS or LAZ data, it could be a land XML, or it could be conventional survey data. Let's go ahead and bring in that DEM. So when we've brought that in, the magenta blob in the center is our raster points. Now with that, those points have the display property turned off, so when I click off to the side, they're still in my model. I can see I've got 1.6 million points in my model. They're just not being displayed. Now to take those points and turn them into a surface, I'm going to click generate button, and I'll generate my tin. And if we'd like to view that surface, we'll click our 3D view button, and we'll click zoom to extents to see that surface that we're dealing with. Now if I'd like to see my plan and my 3D view at the same time, I can tile my views. Now for this, I'm going to pan around so it's a little easier to see what we're dealing with in the 3D view. And here there's some other information I'd like to consider, other spatial information I'd like to consider. So aside from just the common file types for working with surface information or survey data, we also work with a wide variety of standard formats for other data types as well, so including vector data. So here I'm interested in bringing in a line work that I already have for my existing road, so I can bring that in, and that's a shape file. Now I'm going to just make that a little easier to see by changing my line type. And this file, I can see the shape file doesn't have valid elevation data in it, so I can drape this feature by turning that on and turning that off. And then it's set on the surface that it overlaps with. Now I'm also interested in this case, I've got a target stand that I'd like to do my harvesting activities in. I'll bring that in as well. So we've got our vector data in. In this case, I'd still like a little more context for where things are at. So I'll bring in an ortho image. Now here I'm just connecting to a web map tile service, in this case Google, but we could bring in our own ortho imagery if we had it and wanted to use that, or we could use another map source if we wanted to use another map source. So I'm going to save that. Now I could change this right now, but I'm not going to. So I'm going to just leave my default settings as is. So when this gets brought in, that image is in a separate train file as a background. And if I'd like to adjust anything with that, I can click this button here. And in this case, I'd like to wash out that image a little bit, make it less prominent so it's easier to see my contours and other features. And I'll do that here. Now I can see everything that I'd like to see. I'm going to start analyzing my project. So for this, in our cable analysis, well, how our deflection lines interact with the surrounding terrain is going to be very dependent on the type of equipment we're using. So we're going to start by defining our equipment, and then we're going to define the harvesting systems that we're using on it. So here I can see I have 4 pieces of equipment set up with my defaults. I'm going to add 2 new pieces of equipment to this that I'm going to consider using. So for this, I'm going to create a new piece of equipment for a Logger Champ 650, so an LC 650, which is a fairly large modern swing yarder. It's got a head spar height of 18.2 meters. We're going to define our capacity for our drums. So I'll go 560 and 560. And my haul back is a larger capacity, so 1204. Now for this, my weight per length relative to the cable rope that we're using, or wire rope that we're using, I'm going to set that to be, well, I have it tabulated in pounds per feet, but we could change the units if we like. So if pounds per feet for what I run on this is 1.7. So it's using the same wire rope on all the drums. And then we have our max working tensions of those drums. Now for this, I'm going to change my units to be kilonewtons. I'm going to want to use the actual value that I'm using in my analysis. So there's no safety factors being applied behind the scenes. So I'm going to use a safe load for my cable, or the max load, the max force that my winch can apply. So we're going to go with a max working tension of 141 for the main, 141 for this one here, and for my haul back, we'll go 141 as well. We'll hit OK. So I've defined my LC 650. Now, it may be that I have several pieces of equipment to pull from for my contractor pool, or whoever's maybe doing the work. So I'm going to add in another one. And this one I'm going to do something fairly different. So this one's going to be a harvest line system, so a smaller system. It's got a 11.5 head spar height. My drum capacity here is 500 500 and 1,000. My line weight, so it's using a smaller line. And here it should be stressed to the values you're using should represent a particular machine that you have access to, and they can be configured differently. So yeah, don't just blindly use the numbers that I'm putting in here. And then our working tensions, we'll go 105, 105, and 105. So we've defined our equipment. Now if we are going to use the same contractor pool again and again, we'd likely want to set that as our default so we can pull from it in the future without having to input this information. It'll just be there when we open up our next project. We'll hit OK. And now I want to assign that piece of equipment to my logging system. So that, well, we'll consider two options for both those pieces of equipment that we've added. Let's go with the LC650 first. So we'll go with an LC650 with grapple. So the equipment that we'd like to use is the LC650, and here we'll want to define the system that we're working with. And here we can see the translation may be local for what we're working with here. But in this case, we can cycle through and find the system that best represents what we'd like. So I'm going to go with a running skyline with a grapple. I'm going to assign my weight. And for this, the grapple that I'm going to use on this LC650 is an 86-inch TMAR grapple. So I'm going to assign that as being 1105. So I can use that LC650 with that. Now I may want to have that same LC650 set up, but there might be cases where we want to run it with just butt rigging, and we'll reduce the weight for our rigging accordingly. So we'll go with just 100 pounds instead of the other. Now I typed something wrong, so if we wish to edit this, we totally can, and we'll just say LC650 with butt rigging. Next, we will add in our harvest line information. So same thing, I'm just going to set this up to be very similar. Grapple, so I'm going to use the harvest line system. Running skyline. Now this one I'm going to use a larger motorized grapple, so we'll go 1910. And I'll do the same with harvest line with butt rigging. And again, accounting for the lighter rigging. So far we've added in two pieces of equipment, and each one of those pieces of equipment has two possible configurations that we may want to pull from. And again, if that's a common setup where we're working, we'd probably just hit set as default, and then the next time we open the software, that information will appear. We'll hit OK. Now we can start doing our actual analysis on potential landing locations and figuring out what pieces of equipment work well there and how far we can practically yard from a given spot. Now we have our D-line Explorer tool, which allows us to do a bunch of D-lines at once. I'm not going to start out with that though. Instead, I'm going to start out with our single line analysis. So I'm going to create a new D-line. I'm going to just call this D-line 1. And we're going to have a draped feature again. And we'll hit OK. Now I can click here. Now I'm going to just consider this as a possible landing location. And I'm going to draw that being yarded back to here. So I can see that being set on the line. If I'd like to see the profile of my ground underneath that line, I can click the Profile View button. And we'll modify this view to look however we'd like it to look. So if we wanted to see what it's like if we put, say, that harvest line on this, well, we can. We can go over here. We can click New. We can say, well, let's look at what it looks like if we put the harvest line with that big grapple on it. Now here, the type of analysis that we're using, it can vary, and we can set it however we see fit. But for me, I'm going to use the minimum deflection given load. So if we have a standard piece size of, say, 1,000 kgs, how much lift can we expect? So we'll hit this. We'll hit this here. That sets our haulback block station. We can hit OK. So we can see from that location with that piece of logging equipment, we can get about that far, and then we lose our deflection after this little hump here. Now, if we wanted to entertain the idea of maybe setting up an elevated haulback block, we can edit it, and we could say, well, I want to see what happens if we plan on setting that block up 5 meters in a tree. So we can see that gives us the lift we need. We're very close to running ground lead through that particular spot, but we can probably get right to our proposed limits if we'd like to. Now, if for some reason we can't go right to the limits, we can move this around, and well, maybe we don't want to go all the way to the end. Maybe we just want to go to 290. So we have the control to analyze these different situations, and we can use that same configuration to, well, see what happens if we try to get way over here. So if we look at where we've put that, we've run it to there, and we can say, well, let's click this, let's reduce that. So we can try all these different situations with very little effort. And here we can see we're stuck at 192 with this particular setup. But if we want to go with, say, that larger grapple with butt rigging, we can click that. We see we've got better lift. We're still not doing amazing to get over that next hump, but if we bump that up to 5 meters, we can see we're just clearing that break. So again, very useful tool to help us figure out what systems make sense and what we can get from which one. Now, instead of doing this analysis one at a time, so I've got my current D-line selected, we could use the D-line Explorer tool. So with this same concept, we select which system we'd like to use. We select our max yarding distance. We can add a block height on the back end if we'd like, or we can leave it at ground. And we can tell it to search in whatever quadrants we'd like. So here we can click along and we can see how much we're getting from any of these spots that we try. And if we'd like, we can increase our density to really help flush out where we lose that deflection on a given area. So we can hit accept, and then we can do that same analysis on these individual D-lines, and they behave just the same as if they were generated manually. We can move them around if we need to move them around. And we can run that from multiple locations. So we'll go over here as a possible spot, and we can see that, well, we're not really getting a whole lot more by having another landing at that spot, or here, where this landing location covers us pretty well with that large machine. Now, this backside though, we can flush this in, and we can do whatever analysis we'd like along there. And here, if we want to allow the analysis to consider all quadrants, we can turn those on, and we can see how far we're getting from those individual locations. Now, regardless of where I put this second landing, I can see it's going to be very difficult to get our coverage without using this public road for this lower portion. So with that, I'll conclude my video 1 overview, and our next video will cover, well, planning our road access to establish a new landing location.